Hello, this is a demo of Squidward. Squidward is an enterprise IT firewall at AI speed. Traditional firewalls were built for humans and static traffic. With the adoption, enterprise IT teams are struggling with traffic coming both from agents and humans. More importantly, this traffic is non-deterministic. Agents are reaching out to insecure endpoints and they are sharing data with each other in ways that was not possible earlier. This means AI traffic needs an AI-driven firewall solution. This is where Squidward comes in. Let's start with a demo. The dashboard lists all the issues and vulnerabilities that are being flagged by the agents real time. The IT operator can go on the dashboard and see these findings and drill deeper. Let's look at one of these findings. So this particular finding was coming from OpenShell and it was flagged by MITM proxy. The operator can go in and either reject or approve that finding. Once the finding is approved, this is applied directly to the firewall. So historically, the IT operator would have had to go to the firewall settings page, change these rules, and then apply them. Squidward gives them an easy way to apply and update these findings. Not only that, Squidward keeps tracking all the live events happening within the organization and the CVE and other vulnerability. Squidward is constantly looking at the CVE database and other sources where these vulnerabilities are being tracked actively. It is looking at the community reported issues and finding out which issues should be fixed within the organization as well. Using this, the IT operator need not go to 100 sources and find out which of the issues or vulnerabilities they should be tracking. Squidward does that job asynchronously for them 24/7. And since these URLs and these systems are sensitive to an enterprise, Squidward runs 100% locally using local inference, and in this case on the GB10 that is provided to this team. So this is the dashboard that IT operators use. But let's go and now look at the agent that is also available for the IT operator to work on the same database. Now we're looking at the OpenClaw agent, which is connected to the Squidward database using an MCP. We have already run a few commands, and you can see that the operator asked for the open issues used for Squidward, and it came back with some results. The first result is that, hey, finance agent seems to be talking to some IP that it should not be. And there are some issues that it flagged. The operator said these policies look good and they should be applied. And Squidward immediately went ahead and applied these policies to OpenClaw will now go ahead and apply these policies to the finance agent, which will be updated in the next pass. This means the operators need not check all the agents that are being spun up in the entire organization because OpenClaw will constantly run this cron job and then keep them updated with the vulnerabilities it is finding or flagging out. So operators get a very easy interface to use to not only find issues but also manage them and maintain them from one single dashboard. And again, since this is a sensitive data, the architecture of Squidward runs completely on local. From the architecture diagram, we can see that Squidward, the API, the inference, and the database, they all live 100% locally within an enterprise's. This means enterprises can be 100% sure that none of this data is leaving their infrastructure and they own it. In closing, Squidward enterprises IT teams move forward at the AI speed. Thank you.